Hi, my name is Naya Patel. My student ID is 1014163336 and hereby I am presenting you my assignment 4 for COMP3132 Machine Learning. So this assignment is about reducing overfitting in CNN using Cipher 10 dataset. So I will walk you through the code I used and explain how each part helps improve our model's performance and generalization. So in the first step, I imported the necessary libraries and then I load the Cipher 10 dataset, which includes 60,000 small color images in 10 different classes. To prepare the data, I normalize the image pixel values between 0 to 1. And as the normalization is a key because it helps in network train more smoothly. Finally, I split the training data into two parts, one for training the model and one for validating how well the model learns. The next step is I build my first model, which I call the baseline model. This model has many layers. Because of this, it's prone to overfitting. So it performs well on the training data, but it does not generalize as well on new and unseen data. The model uses several convolution layers which help extract features from the images and combined with pooling layer which helps reduce the size of the data. And it ends with dense layers which makes the final predictions. So here I use the Adam optimizer and a common loss function for multi-class problems. This model is then trained for 5 epochs. After training, I plotted the graphs to show how the model did. So one graph shows the loss, like how far off the predictions are during the training and validation. And another graph shows the accuracy, like how many predictions the model got right for both like training and validation. So as we can see, the blue line is for the training and the orange line is for validation. So if the training accuracy is much higher than the validation, then it's a sign of overfitting, as you already know. So this plot helps us understand when the model starts to memorize the training data too well. So next up, I build an improvised version of the model. This model includes two major changes. One is regularization and the next is data augmentation. So here I added L2 regulation to some layers, like which adds small penalty to the large weight. So this makes the model simpler and less likely to overfit. I also use dropout layer which randomly turns off some neurons during the training. So this will force the model to learn more features. So instead of using the original images, I use the image data generator to create slightly modified version of these images. So this means the model sees many different variation of the same image, which helps it to learn generalize better. After the training, the training im- after the training, so I plotted the graphs again. So first these are the two graphs. This is the improved model loss and this is the improved model accuracy. Also, I displayed a few example of augmented images so we can see how the original images are transformed, and this makes it easy to extend the overfitting. So that's pretty much for my assignment. So this assignment demonstrates how we can tackle overfitting in deep learning by using simpler models, regularization techniques, and data augmentation. Thank you for watching.